A study on the handling of averages in three-dimensional graphs at KES 6919. Abstract: in the three-dimensional graph from reference 1, I discovered that the conventional method for calculating averages leads to contradictions, so I am reporting this finding. Introduction: both reference 2 and 3 state that the average is calculated by dividing the total sum of values by the number of items. Formula 1, the average is calculated by adding up all the x sub I values from I equals 1 to n, and then dividing that sum by n. However, using this method to calculate the average results in different volumes. Figure 1 illustrates this. Figure 1. Method: on the left side of figure 1, the observed value R continues for period L, and the observed value R2 continues for period L. These are averaged over a period of 2L. To make the volume V on the left equal to the volume on the right, we solve for R3. R3 equals R1 plus R2, divided by 2, times V2 prime. Where R1 is greater than or equal to 0, and R2 is greater than or equal to 0. Next, we compare the volume calculated using R3 equals the square root of the sum of R1 squared and R2 squared, divided by 2, multiplied by V2. And the volume calculated using R3 equals the sum of R1 and R2, divided by 2, multiplied by V2 prime. V2 minus V2 prime equals the square root of the sum of R1 squared and R2 squared, divided by 2, minus the sum of R1 and R2 divided by 2, which equals the square of R1 minus R2 divided by 4. And this is greater than or equal to 0. The two sides are equal only if R1 equals R2, in all other cases, V2 is greater. In other words, the square root of the sum of R1 squared and R2 squared, divided by 2, is greater than or equal to the average of R1 and R2. Next, the conventional way of averaging is illustrated in figure 2. Figure 2 shows a shape that is a frustum of a cone, formed by rotating a trapezoid. Finally, the method for calculating the average found in this study, namely the root mean square, is illustrated in figure 3. Figure 3 compared to the image in figure 2, the sides are slightly bulged, resulting in a bowl-like shape. Conclusion: for three-dimensional graphs, it is better to calculate the average using the following formula. Formula 2, x equals the square root of the average of the squares of x sub I, where I goes from 1 to n. However, when actually used, the difference from the conventional method is small, so for engineering purposes, a straight line may suffice. For precise calculations, Formula 2 should be adopted. References. Japan Patent Number 5992740 https://www.j-platpat.input.go.jp/c1801/pu/jp-2014-010727/11/ja. Introduction to Statistics in the Era of Big Data, The Basics of Statistics Supporting Data Science, author, Masatsugu Fujie, published, March 20, 2021, publisher, Shizuko Tanaka, publishing company, Gakuyusha Company, Limited. Introduction to Statistics for Data Science, Prediction, Classification, Statistical Modeling, Statistical Machine Learning, and R/Python Programming authors, Peter Bruce, Andrew Bruce, Peter Gedek, translator, Toshiaki Kirikawa, technical supervisor, Shinya Ohashi, published, November 6, 2020, publisher, Tim O'Reilly, production, Beans Network, publishing company, O'Reilly Japan, distributor, Omsha Company, Limited. The end.